a new kind of angles that we're going to see in circles. When you know an inscribed angle, you should be able to find an arc measure for that angle, as well as you can find arc measures. You can find the angle measurements if you know the arc measure. So some things that you need to remember from previous units in order to do well with this unit. The first thing you need to remember is that this angle right here is called a central angle, and that the measure of the arc, AB, is going to be exactly equal to that central angle. So that's a very important thing to remember. It's also helpful to remember that the sum of the interior angles of a triangle is 360. Sorry, 180 degrees. I was thinking of circles and I said 360. So first of all, I want you to know the definition of inscribed angle. So the first thing I want you to do is draw in your note sheet a circle, and then I want you to draw a point on the circle. And an inscribed angle is an angle with its vertex on the circle. A reminder, the vertex is like the elbow part of the angle. It's the part that bends. So this is an inscribed angle. An inscribed angle. I'm going to give it another Greek letter. This is a Greek letter alpha for that inscribed angle. I would like to make a note too that an inscribed angle doesn't have to just look like this. It could also look like this. I could have my vertex of my angle on the circle, but then I could have the angle open up like that. So it, as long as the vertex is on the circle, it's still an inscribed angle, and so this would be that theta angle. Another thing I want to point out is that if I draw the inscribed angle and it cuts off the same arc, these angles would be congruent no matter where I draw the inscribed angle. And I'm going to show you a little animation of that. But the inscribed angle is going to be the same measurement if it cuts off the same arc. The morphemes for inscribe is written into, so it's scribe is right and in is into. So when I write an inscribed angle, it's inside of the circle. So here's an animation showing that that angle doesn't change as long as it cuts off the same chord or arc. It's going to be the same size angle no matter where I draw it on the circle. All of these are inscribed angle with their vertex on the circle, and they all have the same measurement because they cut off the same arc. I also want to point out that the inscribed angle is not equal to the central angle. It's actually, it has a nice relationship. The inscribed angle is half of the central angle, or the central angle is 2 times the inscribed angle. So that's actually the next thing. How do I find the inscribed angle if I know the arc measure? If I know the arc measure of AB, the inscribed angle is going to be 1/2 of the arc measure. So just, here's my picture, here's A, here's B. The inscribed angle would be half of the measure of that arc. This is where theta would be. How do I know arc measure? How do I find the arc measure if I know the inscribed angle? The measure of the arc is twice the measure of the inscribed angle. The rest of today's notes are the example problems. Thank you so much. Bye.